Hello, and welcome back to another video with ItsDrDan, and today we're going to be learning how to use the periodic table. And this is one of those most vital skills that you could ever have in any chemistry course. So if you're someone who is new to chemistry, I'm going to go over the basics on how to read an element that you find on the periodic table and some of the different applications that we can use by learning how to use our periodic table. So this is introductory. Every single class is going to be a different level, so I always recommend knowing your fundamentals. In this video, we'll go through how to tell how the number of protons, number of electrons, how to calculate neutrons, how to apply it to the Bohr atom or the Bohr model, and then we'll also learn how to fill in common textbooks and exam charts that you will find in this. Go at it. Let's learn how to read an element from a periodic table. So the periodic table is something that has all of our elements organized by its property, and they are all identified differently based on their based on their atomic number, the number of protons, and all these little subatomic particles that you were learning about in your chemistry course. What I have in front of us is sodium. So sodium is represented by the element symbol Na, which is the very first thing that we see here. So every single element is represented by a 2-letter or 1-letter abbreviation, and that helps us be able to identify it very quickly, so that way we don't have to spend a lot of time trying to figure out exactly what is this that we are looking at. Above it, you can see that we have the atomic number, which is how all our entire periodic table is situated and organized. Now, what is important about the atomic number is that, well, whenever you see an atomic number, this tells you the number of protons as well as the number of electrons for an atom. And that is because every single atom is inherently neutral, meaning it does not have a charge naturally. They are inherently neutral. So now what else do we have here? Well, we also have this number on the bottom, which is referring to the atomic mass. Now, the atomic mass is our third number, which is also very useful. And what that tells us is whenever we add up all of our protons and all of our neutrons, we will have our mass. So this is protons plus neutrons is equal to our mass above. So, and that's something that's a very common thing. We commonly will round this number to the nearest whole number, being that it represents different versions of each element known as isotopes, which we will cover in future videos about isotopes. So let's try to apply this and try to organize it in a simple model known as the Bohr model. So let's look at this one in the next example. Right. So with the Bohr model, the entire idea with this is for us to be able to organize all of our protons, electrons, and neutrons in a very simple manner. Now, when you are reading your periodic table, you have your atomic number, which tells you how many protons there are. This is what identifies your element. You cannot change the number of protons. It is unique for your element. So we had sodium above. So we have all of our protons and neutrons are found within the nucleus. Now with an atomic number of 11, that means that we have 11 protons inside of our center. So our 11p with a plus tells you protons. Now, how do I figure out neutrons? Well, if you remember from before, the atomic mass, right? So our atomic mass from right here tells us, all right, that's 23, right? We're going to round that up. Now, 23 is equal to protons plus neutrons. So let's do some simple math here. 23 minus 11. How many do we have left? So we have 12 neutrons is what is left. Now notice if I add those two together, that equals your atomic mass. So that's everything that's inside. What about the electrons? The nucleus is in that dense little core right in the middle, but around it are electrons that are moving as extremely fast as a blur around the nucleus in an electron cloud. Now, what early physicists believed is that, okay, well, let's try to organize these things in orbits, which are little circles around each orbit, around the nucleus. The electrons are found equidistant away from that nucleus, trying to rotate around. Now, this model is something that is a beginning model, right? Eventually, we'll realize, oh, this gets a little bit more complicated when we learn the next steps with electron configuration. But for now, it is a nice approach. Now with this, it helps us to be able to explain the periodic table. So let's look at our periodic table and try to understand how can we try to situate electrons in it. Now, so here's a periodic table. When we were looking at this, right, we have sodium is all the way over here on the left. And the cool thing about this thing is it not only tells you electrons, protons, all this useful info, but it also tells you how many levels there are in this orbits, right? So orbits are levels. Or an easier way of looking at this is rows of your periodic table. So if we have, how many rows do we have? If you look here, right, we have 1, 2, 3 until you get to sodium. So how do I figure out how many electrons there are in each of my rows or orbits? Well, it's like reading a book. If you look at your first row, how many elements are there? Well, I can see that I have hydrogen, right, up top left. And then I also have helium over on the top right over here, right? So that's 1, 2. So that means we have 2 electrons in our first one. So why don't we fill that in? So we go back up to our orbit. What we're going to do is we're going to put 2 dots for our electrons. And it doesn't matter 100% where they're at. We're just going to put them in there, right? So that's where it is. Now going back to our periodic table again, how many do I have in the second and third row? Well, count your columns now in that row. So if I look at that second row, well, all right, I see that I have lithium, beryllium, so that's 1, 1, 2, and we'll go across, reading from left to right like a book, and we see we have 3, 4, 5, 6, 7, and then 8. And there's the same number below it, so we can fit 8. So we'll put 8 dots until we run out. Now we got to make sure we don't go over 11 electrons for this example. So we have 2 in the first row, and then we'll have 8 in the next. And we'll put in 8 dots, right? 1, 2, 3, 4, 5, 6, 7, and then 8. Now, how many do I have left? I've put a total of 10 in there so far. We need one more, right? 11 protons equals 11 electrons. So that last one is going to go in our final row because in our final count, we have 11 protons, 12 neutrons, and then 11 electrons. And that is how we can do it for sodium with the Bohr model. Let's go on to further topics of what else we can get from our periodic table. Even though I said earlier, and it is true, atoms are inherently neutral. However, they have the tendency to take or lose electrons that are around them. So remember, protons have to always be the same. We never lose a proton. We only ever lose electrons. They're really tiny. They move really fast. Sometimes easy to misplace. Sometimes easy to borrow them. If you have a cation, meaning that it has an extra or has one less electron, cats are positive. So if you remember, cation means you have one less electron. So let's write that down for ourselves, right? One less electron, one less electron. Now, if you have an anion, or you're thinking an onion, which is a little bit negative because it makes you cry, right? If you have an anion, that means you have one more electron. So keep in mind, you will also be given ions, which are very important to realize when it comes to charge. Charge is going to be something that's a big part of trying to see how are these different species bonding to each other as we're going through all these different examples. So let's try and see how we can organize these with the Bohr model when we are altering our charges. On to our next example. Okay, in our next example, what we're going to be looking at is how else we can try to organize elements and how to read them when you come across them, whether on a periodic table or in different homework problems. So one common way that you will see a lot of these different elements represented is in the following notation, where you have an element symbol, like how we have the one down here with chlorine, right? We have our symbol in the middle. That's generally written with the letter X, just to tell you, okay, here's our symbol. It's very common that this will have a charge associated with it. If it's neutral, it's going to be a 0. If it's positive, it'll be like +1, +2, +3, +4, and so on. If it's negative, same idea, -1, -2, -3, -4. In this case, we just have negative or -1. This is telling you how many more or how many less electrons do you have. from before, if you remember your atomic number, it's very commonly written with the letter Z to tell you, okay, atomic number, how many protons? Or your atomic mass, which is how heavy is it? Protons and neutrons are heavier. Therefore, we add those up to get our total. All right, let's try to practice that. And with ions. So here's our example from earlier. On the left, we have sodium. Now, if you remember, let's practice that again. How many protons did we have? Well, that's going off our atomic number or the number on the top left here. So when we have that, right, we have 11 protons in our nucleus. Now we're subtracting the mass from the number of protons. So when we subtract those two numbers, 23 minus 11, that tells you, all right, well, we're going to have 12 neutrons in my nucleus. Now, what about the charge? Well, it's positive, meaning that it has a much more positive presence. Protons are positive, electrons are negative, meaning that I have more protons than I have electrons in this case. The way to think about this is think of a balance. So when I have one more positive, that means my protons are a little bit heavier than my electrons. So if we have 11 protons, that must mean we have 10 electrons that have that positive charge in this molecule. So we will fill those in. And remember, we have 2 electrons in the first level. We have 8 in the second. 1, 2, 3, 4, 5, 6, and 7, and then 8. So that is a total of 10 electrons, which is how many we have in a positive sodium atom, or ion. Sorry, not atom. Okay. Now, the next one, chlorine. Chlorine's a little bit bigger. One thing that you'll see is that it has 17 as its atomic number. Meaning, how many protons is that? Well, it's going to have 17 protons, right? Those numbers are equal. Next, when we are looking at our neutrons and protons, right? This is what makes up our mass. We add those together. So if you do 35 minus 17, you're going to get how many remaining neutrons are. So we have 18 neutrons in our atom. Now, 17, so we normally have 17 electrons to balance out the 17 protons. But being that this chlorine has a -1 charge, that means we have one more electron because we're more negative. We're more like an anion or more like an onion in this case. So being that's the case, we will fill in our electrons. We have 2 in the first level, 8 in the next. 1, 2, 3, 4, 5, 6, 7, and then 8. And then we're going to have another 8 in the next level as well. And maybe we'll do these different colors just to help show each level. And then let's do gold for the last one. 1, 2, 3, 4, 5, 6, 7, 8. And they don't have to be in a specific spot. We're just trying to show that we have 2 electrons in that first level, or n is equal to 1. N is equal to 2, as in row 2 is 8. N is equal to 3 is another 8, as I have written in the little chart here, like how we looked in the periodic table before. And that's how you fill in a Bohr model for different ions. Let's go into a very common exam problem where we try to calculate protons, neutrons, and electrons with something you can find in most tests or homework. It's very commonly given at schools all across the country. Let's go to it. All right, a very common problem that you get all the time in tests, quizzes, homeworks is to fill in a table just like this one. Now, the whole idea about this table is that you are given a piece of information and you need to try to solve the unknown pieces from what you were given. So you got to complete the table. Now, what thing you see is that, all right, what do I give you? Well, you have the symbol, you have the atomic number, the mass, number of protons, the number of electrons, neutrons, charge. So it's everything that we got from before. So if we are to fill this out, well, let's see what context clues are. If we know the number of protons or the element symbol, then we can figure out the rest of the information really easily. In this case, for the first one, we have the number of protons, 16. That's a fingerprint of a molecule, right? That's exactly the number of any of these species. So atomic number is equal to the number of protons. So let's try to figure out what it is. So we're looking for number 16. And when we look at the periodic table, well, real quick, we can see that, oh, sulfur over here is number 16. So now we're not going to copy down the mass from this. We are using what is given. Only the atomic number and symbol are we going to take from the periodic table. So we will use our own information. So we have sulfur is our element. So let's fill that in. So we have S, and it has a symbol of 16. Now, I gave you the mass, which is 32 for this particular version of sulfur. So how do you figure out neutrons? Well, neutrons is, our atomic mass is neutrons plus protons, right? So being that we have our mass of 32, we can do 32 minus 16 protons is going to be equal to 16 neutrons for our problem. So we can fill in that piece of information. So 16 neutrons is how many I have. Now, what about electrons? Okay, well, we have another little formula here, is that charge is equal to protons plus electrons, and then I give you a little key that cations are positive, anions are negative, meaning more electrons or less. And one thing that we can see is, okay, we had a charge of -2. So if we go back down, that means that we're more like an anion, right? We are more negative, so we have more electrons. Now, we also see that protons are equal to, or protons plus electrons equals our charge. So if we have a charge of -2, and then we have 16 protons, we want to know how many electrons. Well, if we do minus 16 or -2 minus 16, we'll get a -18, which is 18 electrons if we do the little algebra behind it. So 18 electrons. And that's how you fill these out. So I bet you will have homework problems like this in your class. Most classes do. And it's a practice. Can you fill it out? And if you wanted to put this in one step farther in the atomic notation like we had earlier, we could do that where, okay, well, I have sulfur as atom 16, and it has a mass of 32 with a -2 charge. You could fill in all of the information given to you and with that symbol, which is really, really useful. All right, the next one, copper plus and 36 neutrons. That's all we have. But we can use our periodic table to figure out how many protons and what the atomic number are. Remember, those are equal to each other. So let's find copper on the periodic table. That's a metal. That's going to be right here in the middle. And we can see it right here, right? So copper, that is number 29. And just from earlier, sulfur was over here, just to circle that. So 29 is our number of protons and our number and our atomic number as well. So let's fill that in. So 29. And then we also have 29 protons. Now, what can we do next? Well, we have protons and we also have the neutrons as well. So we can add up those two things together to get our mass number. So 29 plus 36, that's going to be 55 for our mass. So we have those. We could fill in our little guy over here like how we did before, 55 and 29. Good practice to do. I recommend it on all your homeworks. Now, what else do we need? We need the number of electrons and the charge. Well, if you notice over here on the problem, it had a little positive charge written next to it, which tells you, okay, well, if I have this positive here, that means that there's one less electron, right? This is a cation. Cats are positive. So if this is a cation, that means we have one more proton. So we have a total of 28 electrons and a +1 charge. And I can show you the math for that too, right? So if it's +1 and we have 29 plus our electrons, we could see that, all right, well, if I subtract those two numbers together, we will get -28, which is electrons because they're negative, right? And that's how you can solve this type of problem. Well, I hope that this video helped. This goes through all the different problems that you'll commonly see for just the basics and the fundamentals of how to count protons, electrons, and neutrons when you are in your chemistry class. So I will try to leave it on that screen here just so you have all those little tips and notes. But good luck to you, and there will be more videos to come. And this is Dr. Dan here. Please feel free to hit that like and subscribe button if this helped. And I hope to see you in future videos. Thank you, and I'll see you all later. Bye.